Hi there, my name is Catherine Murtha. I'm a registered dietitian and an educator, and I'm here over your shoulder to walk you through all the math you need for the RD exam. In this module, we'll look at the math on its own, making sure you are a pro at the foundational skills you'll need for later on. But luckily for you, at Bridge, we've narrowed down all the math into just two skills: dimensional analysis and percent. So this lesson and the next one are super important. And the goal is to have you feeling like a pro at these two skills. In this set, we're looking at dimensional analysis, often shortened to DA. You may have seen this method before, but if you haven't, no worries. We are going to make sure that it is clear so that you never have any problems. Dimensional analysis is a way to convert between units, and it's used all the time in nutrition practice. Whether you're adjusting a recipe, calculating fluid needs, or interpreting food labels, DA is the tool that helps you move from one unit to another with confidence. To do this, you'll start with something called the given. That's what the problem gives to you to work with. For instance, if you have 160 ounces and want to know how many cups that is, then 160 ounces is your given. To move from ounces to cups, you need to know the relationship between those two units, and that relationship is called an equivalence statement. In this case, the equivalence statement is 1 cup is equal to 8 ounces. Those two values are equal to each other. But the question I hear over and over again is, well, do I multiply or do I divide? If you use dimensional analysis, you will get it right every time, because dimensional analysis lets you convert by using that equivalence statement as a fraction. You set it up so that the units that you start with, your units that you're converting from, get canceled out. And what you're left with is the units that you want, the units you are converting to. By focusing on the units, you won't have to guess whether to multiply or divide. The structure of the setup will guide you, and the units will cancel themselves out logically. So let's walk through the structure of a dimensional analysis problem more closely. Every problem starts with the given. Again, that's the number and unit provided in the question. That's what you're converting from. It's your starting point. And once you know your starting point, you can identify the unit that you're converting to. That's your to unit. But to make this conversion, you need an equivalence statement. This is a known relationship between two units, like 1 cup equals 8 ounces, or 1 gallon equals 4 quarts. These statements are equal in value, just written in different units. In dimensional analysis, we use these equivalence statements in fraction form to help us cancel out units. You write the fraction so that the unit you are starting with is on the bottom and the unit you're converting to is on the top. This way, the starting unit cancels out and you're left with the correct one. For instance, let's look at this 1 pound equals 16 ounces equivalence statement. Those two values are equal to each other. If I give you a pound of raw chicken, it's 16 ounces. And so 16 ounces is equal to a pound. Since they're equal to each other, we can write two fractions out of this equivalent statement. We could either say 1 pound over 16 ounces or 16 ounces over 1 pound, because 16 ounces is 1 pound, and so what we're really writing is 1 pound over 1 pound. Since these two values are equal to each other, it doesn't matter which value is in the numerator and which value is in the denominator. There's quite a few equivalent statements you need to know for the RD exam, but all of them will be equal to each other. So 1 tablespoon is 0.5 ounces. You could write this fraction as 1 tablespoon over 0.5 ounces or 0.5 ounces over 1 tablespoon. And then these equivalent statements you'll put into your dimensional analysis, where whatever the units you're given, those are the units you're converting away from. Those are the starting point units. Those units will automatically go in the bottom. And the unit that you want to convert to are the units that go in the top. Notice these have different units in them. But since they're equal to each other, it does not matter which value is in the top or the bottom of the fraction. And so knowing these equivalent statements makes conversion problems go so much more smoothly, especially if you use dimensional analysis, because the structure is always the same. You start with the given, multiply by the appropriate equivalence fraction, and cancel the units as you go. So let's do some example problems, starting with that same problem I introduced before. How many cups are in 160 ounces? This is a dimensional analysis problem because we're converting from ounces into cups. All we need to do is change the units. And when we use dimensional analysis, we use this setup right here. Now we need to know the equivalence statement in between cups and ounces, and I'll tell you why. So 160 ounces is our given. We're going to put it right here in the from box. 160 ounces is our given. And then remember, whatever units are in the top from box go in the bottom from box. So if we were to set this up, it would look like this: 160 ounces times however many cups are in however many ounces. What do I mean by that? We need to know the equivalence statement in between cups and ounces. And this is another one that you should absolutely know for the RD exam. The equivalence statement between cups and ounces is that in every 1 cup, there are 8 ounces. And since this is equal to each other, we can write 2 fractions out of it. We can say 1 cup is 8 ounces, or 8 ounces is a cup, because remember, 8 ounces is a cup. So we're basically writing 1 cup over 1 cup. Now, in our dimensional analysis, we need to pick the units that match our conversion statement. We have cups in the top and ounces in the bottom. So we would use this equivalence statement right here. Even though it is equal to that equivalence statement, we want the equivalence statement with cups in the numerator and ounces in the denominator. And we need ounces in the denominator because the whole point is to get these units to cancel out. So when we plug in this equivalence statement, we'll take 160, multiply by 1, and divide by 8. And when we do that, we get 20 cups because ounces cancels out. And that's the whole goal of dimensional analysis, to cancel out our units. Let's do another one. This problem says we have a recipe that calls for 1.25 gallons of milk, but the milk vendor is only able to deliver it in quarts. So how many quarts do we need to use for 1.25 gallons? Well, 1.25 gallons is going to be our given, and what we're converting to is quarts. So this is a dimensional analysis problem. We're just converting units here. And since we're using dimensional analysis, we'll use this setup right here. The given is 1.25 gallons. And whatever units we're converting from automatically go in the bottom. So when we set up our dimensional analysis, we have 1.25 gallons as our given. These units automatically go in the bottom so that they cancel out. And the units we're converting to are quarts. So what we need to know is the equivalence statement between gallons and quarts. This is another equivalence statement that CDR expects you to be able to pull off the top of your brain at any moment. But don't let that stress you out right now. We are still just in the very beginning of learning how to do all of this. 1 gallon is equal to 4 quarts. This is an equivalence statement. And since these two values are equal to each other, we can write them as 2 fractions. What would those fractions look like? 1 gallon over 4 quarts or 4 quarts over 1 gallon. And they mean the same thing. They're equal to each other. It's just a freaky way of writing 1. Now, when we look at our dimensional analysis, we need quarts on the top and gallons on the bottom. So we would want to use this equivalent statement right here. We'll plug it in to our dimensional analysis, 4 over 1. So we'll take 1.25 gallons, multiply it by 4, and divide by 1. And out of that, we get 5 quarts. It's quarts because the only other units here, gallons, cancel out. Shall we try another one? This problem is a little bit more challenging. It says we want to triple a recipe that calls for 1.75 pints of chopped carrots. That right there is our given. It's a number and a unit. It asks us to convert that into cups. So this is a dimensional analysis problem. And since it's a dimensional analysis problem, we'll use this formula right here, where we put our given 1.75 in the from box, 1.75 pints, so pints will automatically go in the bottom, and what we're solving for is cups. Now we need to know the equivalence statement between cups and pints. Another equivalence statement CDR expects you to know for the RD exam. If you don't know, 1 pint has 2 cups in it. Think about a pint of ice cream. It's got 4 half-serving cups in it. There's 2 cups in a pint of ice cream. I don't know how many pints of ice cream you're eating, but that's how I remember the number of cups in a pint. Now, this equivalence statement, right? It's equal. And so since it's equal to each other, we can write it as 2 fractions. What would those fractions be? 1 pint over 2 cups. 2 cups over 1 pint. They're equal to each other, but we need the equivalence statement that matches the units in my dimensional analysis. We need pints on the bottom so that it cancels out with the pints in the given. We want this equivalence statement right here. There's 2 cups in every 1 pint. So if we need 1.75 pints, then that would be 3.5 cups because pints cancels out. But wait, we're not done here. If you reread the problem, it says that we are tripling a recipe. And since we're tripling a recipe, all we've done here is convert the 1.75 pints into cups. We still need to take this cup and triple it times 3. Why? because this recipe is being tripled. So if every recipe calls for 1.75 pints of chopped carrots, that's 3.5 cups of chopped carrots. Since we are tripling that recipe, we're going to need 10.5 cups of chopped carrots. So as you work your way through the course, I'll continue to recommend that you try the practice problems on your own by pausing the video. You should favorite or bookmark videos that you think you need more practice with. Try not to get discouraged if you get them wrong. You don't have to get them all right straight away. We're still learning here. Drop any questions below or bring them to the Bridge community page. You are not alone in this. I'm so glad you're here. And as always, I will see you in the next one.